So synesthesia, I love to always look at the word, where it comes from, right? The etymology. So from the Greek, syn, to join, and aesthesis, perception. So this idea of joining different perceptions. Now in the brain world, how do we define it? Well, we say it's basically a neural phenomenon in which a stimulus in one sensory modality consistently and involuntarily activates sensory perception within another sensory pathway. It typically occurs in about 1 to 4% of the population. So if you have synesthesia, you are quite a unique individual. Sort of looking at this in numbers, also some people say it's like 1 in 25,000, 1 in 23. The reason why I put these different statistics is to really show you that it's a mixed bag depending on the types of battery of tests that are done to assess whether people have synesthesia. So it's not necessarily, we don't know is my point, really the true number of how many people have this particular experience. To give you an example, these are actual examples from case studies. So for example, the word car in an individual actually causes the perception of the taste of vanilla. So literally when they hear the word car, they taste vanilla. Another example, somebody sees the letter D and they actually perceive the color green. And then for somebody in the case of sound, they'll hear a C sharp note, like so if I were to push C sharp on the piano right now, and they would literally perceive a yellow line in front of their visual scene. So what I've circled in red there, that's what we call in the field the inductor. And what's in blue is the concurrent. So they're just the fancy terms. And so concurrent basically means the induced perception. Now, these are just examples. This is not the case for everyone at all. It may very well be the case that somebody hears C sharp and it actually gives them a perception of chocolate. So it's really, it's personal. It really is very personal. And what also brings up the question of, well, if it's so personal, then maybe it has to do with your own personal experiences in life, right? So maybe this is not necessarily a potential genetic, and I'm putting quotes, issue or brain issue. Maybe it's something that from birth, somehow it's about some sort of sensory perception that you got habituated to and just kind of learned it. And I put all of that with question marks. So let's look at some key characteristics. And I'm going to walk through them because it's key to really understanding how we define synesthesia as opposed to sensory associations. So one is, it tends to be, no, not it tends, it is involuntary and automatic. So what this means is that it's not a conscious decision you make. So that word car and vanilla taste is something that just happens to that individual. So that's a really key component, that it's involuntary and that it's automatic. So that means you're not choosing those associations. Another characteristic is that it is and has to be consistent, which means that every time the word car occurs, it will always be vanilla, so it does not change over time. Now, this is actually a question mark in the research. More current research today has shown that some individuals, when they've actually looked at them throughout their lifetime, will say that it tends to change slightly. So even though, for example, that example of the C sharp with the yellow line, that it may be that, yeah, C sharp still elicits yellow, but maybe like an orangey line. Or maybe it's no longer a line, it starts to curve. But the idea is that it is typically always consistent. It does not change across the lifespan, but there are cases in which it potentially does, but if it does, it's slight. Another characteristic is that it is idiosyncratic. So as I was mentioning with those examples, it manifests itself in a personal way for the same stimulus. So this really goes to show that every individual really perceives something different. It could well be the case that there are similarities between individuals, but that's an open question as to why. Another characteristic is that most types of synesthesia are unidirectional. So what this means is that, as the example here, a number may evoke a color, but that color will not necessarily go the other way. So that color will not evoke the number. So for example, the C sharp case, C sharp always equals a yellow line, but a yellow line does not necessarily equal C sharp. So a yellow line could then elicit in somebody else, let's say, chocolate. Or even in the same person could elicit chocolate or could elicit, let's say, B flat. So it's not bidirectional. Another key characteristic is that synesthesia is additive. So what that means is that it adds to normal perception. So in the case of that, the car in the vanilla example, so that individual will see, let's say, an actual car, be walking to their car, getting inside a car, and all of those regular perceptions of identifying the color of the car, the size of the car, the type of car will be there, but in addition, they'll have that vanilla experience. So that's what I mean by additive. Also, synesthesia is an emotional experience. Most individuals who describe their synesthetic experiences always mention the concept of emotion being involved, always mention that it's something that evokes a very intense emotion. It tends to be on the intense side as opposed to no emotion at all or even a slight emotion. So then that brings up this really interesting question, especially when it comes to creativity, as to, you know, maybe that's why we see a lot of instances of artists who have synesthesia creating highly emotional works, whether it's in music or painting or literature or really any art form. Another interesting sort of feature of this emotional experience is that while it tends to be positive in many cases, there are cases of individuals who have related that it actually is a very negative experience, and they actually in fact, I had not too long ago with my undergrads where I teach this course on music cognition, and when we talk about synesthesia, and I've had students who have synesthesia, and some of these cases, and I remember two in particular, they told me they're like, it's a horrible experience. They actually found it very negative, and they've had it since infancy, and they actually, because it was so horrible, they taught themselves to not think about it anymore. So it goes back to that additive issue, that it's something that they then learn to consciously suppress. So that's really interesting now, because remember, we mentioned it's involuntary, it's automatic, but in some cases it looks like some people, especially when it has such a negative effect on their experience of every daily life, that they've had to learn to sort of tone it down, and they've used a lot of different association mechanisms to do so. So this question of when does it arise, it does tend to arise in most cases that I've read in the case studies is that it's since childhood. So it does occur since infancy, which therefore brings up the question of, is it a genetic issue? That's a big question mark. We don't know. So in terms of that question, what you can do is look at family studies, right, or twin studies. And the point is that it's actually it's all over the place, the data. That's what we're really saying. And also what this brings up is says, well, if we can't really see a genetic influence here, and certainly we haven't identified any gene that's directly related to this because it's a higher cognitive ordered experience, then potentially it's about a learning environment. And I'll bring this up because, so you can think in terms of, when you learn colors and let's say fruits, right? And so, if I were to say right now, banana, you automatically probably imagine yellow, right? Apple, green, red. So then it brings up this issue of, because some synesthetic experience are highly correlated with these types of everyday associations, then, maybe it's something that's learned, and since we don't have a genetic explanation to it, it's an open question. That's my point. With respect to the later in life acquired type of synesthetic experiences, they tend to be acquired due to, and this tends to be rare, due to brain injury. So, especially we see this in older individuals. Let's say stroke occurs, or they're in an accident of some kind that leads to a very specific brain injury in, let's say, the parietal lobe. Remember, the parietal lobe is towards here at the top. We have frontal lobe here. In the back is the visual cortex, and the temporal lobe is where the auditory cortex. So the parietal is a really important cortex area that brings really color, form, shape together. So there's that hypothesis that perhaps, let's say if somebody has brain injury that directly affects this parietal part of the brain, that maybe that is related to explaining synesthetic experience. So again, an open question. Another type of synesthesia that arises is due to, it's induced by hallucinogens, so this would be known as the pharmacological type of synesthesia. These are cases where, now, the reason why I don't want to really call it synesthesia is because these tend to be temporary situations, right? Let's say somebody who's under the influence of a particular hallucinogen will report highly intense synesthetic experiences, but as soon as the drug effect goes down, they no longer. So that's, I want to be careful with calling that an actual synesthetic experience. A little more information about sort of the stats related to this. About 60 different types have been identified, as well as about 150 different forms. So what I mean is that it's not just sound and color. You literally can have sound and taste. You can have words with color, letters, numbers. I mean, it's really a whole host of different kinds, and I'm going to show a little slide with a particular example. Again, it's usually classified by the inducer and the concurrent. So for example, music taste, example, we have music is the trigger, taste is the resulting sensation. The most commonly studied type is the grapheme color type. So that's the one where most research has identified, and so that's the one that tends to come up in all the research. And in one of the brain examples I'm going to give, it's based off of that kind. And then all types vary within synesthete. So I did mention that it's a very personalized experience. So this really goes to show that it really is highly unique, and all these types the map is very wide ranging. To give you some examples, what I mean by grapheme color, you can see here the different letters, right, have different colors. So for one person, what A and M will be red, somebody else could be that D and O are red for them. That's what I mean by the variability. So there can also be multiple types. So there's grapheme color and sequence space. So not only do you actually have a color associated with a letter or a number, it actually is in a particular spatial arrangement. That would be kind of like a double type. We also see this sequence space ring appearing type thing. So for example, this is a report of somebody who apparently associates months with color, but also associates months along an actual visual ordering in their visual space. Again, this is just to give you a sample of the variety available, and there are many more. Really, it's up to whatever, really up to your imagination. So do we have any answers as to how this arises? So there are two neural mechanisms to explain all of this. Again, they're big open questions. One of them is called the cross-activation model. Basically, I tried to really put this to the core. So it refers to hyperconnectivity, so really intense connectivity between two cortical regions that cause stimulation in one cortical region to activate a connected cortical region. And so because you have two cortical regions being activated at the same time, this is what's causing the dual sensory experience. So just to see this here, we have the non-synesthete, right? You don't have the experience, but in the synesthete, it's showing the inducer, right, leads to the concurrent experience. And the idea of the the non-synesthete versus the synesthete is that the non-synesthete just doesn't have those double cortical regions being activated, so it doesn't experience it, but the synesthete does. Okay. Related to this, it's what's called the hyperlink model. So the idea that so it's known as the parietal hyperactivation. Remember, parietal lobe is this part of the brain that I was showing up right here on the top. And as I mentioned, this area is extremely important because it's really about constructing it brings all this information of the visual cortex as well as also in the auditory cortex together for you to understand the visual scene so you can process the world. So it's interesting that we would see this in the parietal area, that if synesthesia is about this highly intense visual, auditory, perhaps tactile, smell, taste experience, then it makes sense that we would see hyperactivation in the parietal lobe because that's where we really are bringing all this information together. The second theory is known as the disinhibited feedback model or top-down model. So the idea simply put here is that synesthetic brains lack certain feedback mechanisms from higher cortical areas that should suppress the activation of lower cortical areas. So just to look at, here's the non-synesthete from the little diagram here. You can see that the information coming from the higher order, so the other cortical area, is not, we're not seeing this suppression in the way we do with the synesthete, right? So we get suppression in the non-synesthete, no suppression in the synesthete. So that would be to say that this feedback connection is not happening, basically. So that's why you're going to have this multi-sensory experience simultaneously. So the next question we can ask is, well, is it a structural thing? So is it literally brain areas, brain mass changes, or is it this functional issue? And so studies have shown that there happen to be, yes, differences in the actual neural structure in synesthetes when you compare to non-synesthetes. And for example, again, this is for grapheme color I mentioned. Those are the most popular situations that have been tested in the lab. And it turns out that for grapheme color and a few tone color synesthetes, there is increased gray matter volume in this part that's in red, known as the fusiform gyrus. So this part, so there's more gray matter. Then we also see decreased gray matter in what we call the anterior left fusiform gyrus, which is the little green area, and then decreased in this part of the visual system. So again, I mean, to take home message here is that we do see some sort of increased gray matter in particular parts of the brain and decreased gray matter in particular parts of the brain for the synesthetes versus the non-synesthetes. So this is really strong evidence that, look, this is an actual structural, a neurological situation here that's affecting the higher cognitive perceptual experience. If we move on to the next slide, this is a very complicated slide taking into account an enormous amount of data, but hopefully you can see, hopefully you can already guess who's the synesthete versus the non-synesthete. So this is basically a map of connectivity of multiple parts of the brain being activated. So you can imagine the one where you have this hyperconnectivity. This is the synesthete versus the non-synesthete. So what it's showing is that there really is a full-on activation of multiple connections of neural pathways happening in the synesthete, and perhaps giving credence to that model of a lack of feedback inhibition that we would see in the non-synesthete. So now to this question of association, again, this is trying to make that disambiguation between the synesthete versus the non-synesthete. So we have these classic experiments that were done in the early 1920s, particularly by Kohler, a German psychologist. And so he realized that people do not make these non-arbitrary mappings between speech sounds and visual shapes. So what he did is that he would give these sort of highly star-shaped figures versus these rounded, and he would ask people to match the sound kika or boba. And people would match the kika, so the sort of like these very sharp corners sound with the visual image, and then the more rounded sound with the rounded figure. So the idea here is saying that whether you're synesthete or not, we all make these cross connection of senses and mappings that are similar. So again, this is trying to disambiguate whether it's actually a truly neurological issue, which we have seen there is data for it, but also what does this mean at the higher cognitive cortical sensory perception question. And so that's why it's still an open question as to whether it's genetic or not and purely neurological versus something that is learned. We can go back in history. I've been trying to always give a little bit of history in our different topics. Isaac Newton, well, he's not known to have had synesthesia, but he did this idea of correlating sound with color. He actually, in his treatise of optics in 1704, he actually assigned each of the 7 colors, right, on the visible light spectrum to the 7 notes of the C major scale. This we know it's pretty arbitrary. There's no deep correlation here because the frequencies of sound and with the frequencies of color do not match in such a way, mathematically speaking. But it's interesting to know that we already have somebody looking at it really from a scientific perspective and trying to understand, you know, is this possible, or why do I perceive this, or why do other people perceive this? Another case study is Kandinsky. Some of you may know his work. He is known to have had a synesthesia, and he literally saw colors when he heard music and heard music when he painted. And so actually a lot of his paintings, he has named them after symphonies. And so for him, literally a single note was equal to an actual hue of color, right? And he said, the sound of colors is so definite that it would be hard to find anyone who would express bright yellow with bass notes or dark lake with treble. So literally, he would listen to music and paint, and vice versa. He would say that, you know, my paintings are a symphony, and he actually did a lot of work with musicians as well to correlate that visual, auditory / symphonic painting he was making. Just to give you a sense of how we've come to study the concept of synesthesia, this is the history from 1790 all the way to the 1990s, and you can see a big rise between 1880 and 1920. Kandinsky did make this pretty sort of a hot topic at the time. Again, he did work with musicians to create these symphonic pictorial representations. You can almost think of Mussorgsky's Pictures of an Exhibition. Again, it's on this concept of visualizing sound and symphonies. And so this really goes to show, and again, this is also during so this is before Surrealism, this is the Dadaist movement, the end of Impressionism. So it makes sense, right? Artists are really thinking in this way. It was a hot topic, a lot of research. It came down in terms of thinking about it from the scientific perspective, started to come back up in the 1990s. And today, I think we would probably be slightly up, maybe not too much, but slightly up. So it's also become a big question today. In terms of that question of how similar and how different are these experiences? So there have been studies looking at Scriabin versus Rimsky-Korsakov. And just to show you, this is I love this table because it shows that for the different major tonalities, they actually perceive different colors in some places, but similar colors in other. So for C, Scriabin literally perceived red, Rimsky-Korsakov white. But if we look at the flats here, they're kind of in the dark blues, grays. So that's interesting. So there's this idea that certain colors do correspond to particular harmonies. So what does this mean? I don't know. Simply that perhaps also, well, we also have to consider that a lot of these musicians did know each other in their work, so who knows, it could also be between conversations with each other or their audiences. And just in general, that question of the Kika Boba example, that perhaps it's this merged experience of learned associations with also these automatic associations. So I thought I'd just give you a little bit of that. Moving forward into technology, high tech, remember we ended with the robotics and artificial intelligence. So there's a really interesting case study, and this is where I'm going to show you guys some videos. where we have an individual. He is a working artist, so Neil Harbison, who's from Barcelona in Spain. And he actually uses an implanted device, what he calls an electronic eye, and it acts as a sensor, as a color sensor that literally sends frequency information to a chip that's implanted in the back of his head. So he's actually considered the first human cyborg. And I'm going to share a video with you right now. He gave a TED talk about this because who better than to hear it from the actual individual himself.
Well, I was born with a rare visual condition called achromatopsia, which is total color blindness. So I've never seen color, and I don't know what color looks like because I come from a grayscale world. To me, the sky is always gray, flowers are always gray, and television is still in black and white. But since the age of 21, instead of seeing color, I can hear color. In 2003, I started a project with computer scientist Adam Montandon, and the result, with further collaborations with Peter Queixe from Slovenia and Matheus Lizana from Barcelona, is this electronic eye. It's a color sensor that detects the color frequency in front of me and sends this frequency to a chip installed at the back of my head, and I hear the color in front of me through the bone, through bone conduction. So for example, if I have like, this is the sound of purple. For example, this is the sound of grass. This is red, like that. This is the sound of a dirty sock, which is like yellow, this one. So I've been hearing color all the time for 8 years, since 2004. So I find completely normal now to hear color all the time. At start though, I had to memorize the names you give for each color. So I had to memorize the notes, but after some time, all this information became a perception. I didn't have to think about the notes. And after some time, this perception became a feeling. I started to have favorite colors and I started to dream in color. So when I started to dream in color is when I felt that the software and my brain had united, because in my dreams, it was my brain creating electronic sounds. It wasn't the software. So that's when I started to feel like a cyborg. It's when I started to feel that the cybernetic device was no longer a device. It had become a part of my body, an extension of my senses. And after some time, it even became a part of my official image. This is my passport from 2004. You're not allowed to appear on UK passports with electronic equipment, but I insisted to the passport office that what they were seeing was actually a new part of my body, an extension of my brain, and they finally accepted me to appear with a passport for them. So life has changed dramatically since I hear color, because color is almost everywhere. So biggest changes, for example, is going to an art gallery. I can listen to a Picasso, for example. So it's like going to a concert hall because I can listen to the paintings. And supermarkets, I find this is very shocking, very, very attractive to walk along a supermarket. It's like going to a nightclub. It's full of different melodies. Yeah. Especially the aisle with cleaning products. It's just fabulous. Also, the way I dress has changed. Before I used to dress in a way that it looked good. Now I dress in a way that it sounds good. So today I'm dressed in C major, so it's quite a happy chord. If I had to go to a funeral, though, I would dress in B minor, which would be turquoise, purple, and orange. Also, food. The way I look at food has changed, because now I can display the food on a plate so I can eat my favorite song. So depending on how I display it, I can hear and I can compose music with food. So imagine a restaurant where we can have like Lady Gaga salads as starters. I mean, this would get teenagers to eat their vegetables probably. And also some Rachmaninoff piano concertos as main dishes and some Bjork or Madonna desserts. That would be a very exciting restaurant where you can actually eat songs. Also, the way I perceive beauty has changed because when I look at someone, I hear their face. So someone might look very beautiful but sound terrible, and it might happen the opposite, the other way around. So I really enjoy creating like sound portraits of people. Instead of drawing someone's face, like drawing the shape, I point at them with the eye and I write down the different notes I hear, and then I create sound portraits. Here's some faces. Yeah, Nicole Kidman sounds good. Some people I would never relate, but they sound similar. Prince Charles has some similarities with Nicole Kidman. They have similar sound of eyes. So you relate people that you wouldn't relate. And you can actually also create sound, concerts by looking at the audience faces. So I connect the eye and then I play the audience's faces. The good thing about this is that the concert doesn't sound good. It's their fault. It's not my fault. And so another thing that happens is that I started having this secondary effect, that normal sounds started to become color. I heard a telephone tone and it felt green because it sounded just like the color green. The BBC beeps, they sound turquoise. And listening to Mozart became a yellow experience. So I started to paint music and paint people's voices, because people's voices have frequencies that I relate to color. And here's some music translated into color. For example, Mozart, Queen of the Night, looks like this. Very yellow and very colorful because there's many different frequencies. And this is a completely different song. It's Justin Bieber's Baby. So it's very pink and very yellow. So also voices, I can transform speeches into color. For example, these are two very well-known speeches. One of them is Martin Luther King's I Have a Dream, and the other one is Hitler. And I like to exhibit these paintings in the exhibition halls without labels. And then I ask people, which one do you prefer? And most people change their preference when I tell them that the one on the left is Hitler and the one on the right is Martin Luther King. So I got to a point when I was able to...
Okay. All right. I hope you guys enjoyed that. Okay. So moving forward, I had to wait till we talked about the Martin Luther King and and the Hitler because that surely, again, this brings up this question. So the reason why I have you guys see that is because this is a current case of a human being who is actually, it's created with technology, the synesthetic experience. You can only imagine now, we were talking about last week with respect to how we can now have, right, a third arm. We can create now even a third, probably a third, fourth hand, a completely different way of thinking about how we create art now. So moving forward into other types of virtual worlds, I wanted to just cover really quickly, because there's some burgeoning work in this with respect to music and music composition. Virtual reality versus augmented reality and merged or mixed reality, just so we're clear on what all of this means. Virtual reality literally refers, so it's when you put the Oculus goggles on, right? And so you are literally entering into a synthetic virtual world. So completely, you're no longer in the real world, you've entered into that space. A lot of research is being done in this area to make it a very visceral experience, which is different from augmented reality, because in augmented reality, you still are in the real world. It's just that you have now a device that allows for this digital experience to be added onto your actual real world experience. So you may have already have this possibility or even technology on your phone. There are certain apps that allow for this. Maybe you have the type of similar to the Google glasses, or literally in your phone, you turn on an app and you can be looking, let's say, at whatever's in front of you, and with the app, then you can visualize, let's say, animals there or something. And then emerged reality, perhaps you've seen this more in the movies, in which literally now you're interacting with and manipulating both the physical and the virtual environment. So you have these screens, right, where you're still in your world, but now you're moving things through space almost. So that is one which, also, this is being used, now it's entering into advertisement, kind of merging that with augmented reality. In terms of, let's say you want to buy some furniture and you want to picture it in your home, right? So you can use the app and then merge it onto a screen to see how it would visualize in your actual space. And you can imagine in multiple different contexts. So having this in mind, how it relates to the music world. So there's some really interesting work that's actually started in 2015. So the Royal College of Music in London, England, actually decided to create what they call a virtual performance simulator. So this is really, the idea came about with, so those of you who are musicians know that the more you practice in front of an audience, the better, right? Because you get accustomed to not only a bunch of strangers looking at you, but you also get accustomed to how people can react possibly to your performance, and you just become more comfortable on stage. So this group that actually was a set of researchers in London with Italian designers and a whole host of people came together to build this virtual performance simulator. And I'm going to take us to the video of it. That's really an innovative way of thinking about how to use this technology for the purpose of actually simulating a real concert environment, and it gives the chance to musicians to practice. And even they have a judging panel, so you can really go through the entire motions of that. And we couldn't really hear very well the flutist and her reaction to that, but in the research that's been done further on this, a lot of musicians actually will state that they appreciated it because they literally felt that they were going through the motions of performing on stage, as well as if they had their panel of judges sort of being critiqued and answering back and forth with them. So that's actually a very nice way to facilitate this whole training experience for musicians. And I think it's also being now brought into the public speaking and debate area for those people, who have stage fright and don't like to speak in front of a public. So that I can already see that entering into more commercial domains, right, of how to help people with practice and how these virtual environments can really make you feel like you're physically in it. Another wonderful example, you may be familiar with it, especially if you're in California or in the Los Angeles area. So the Los Angeles Philharmonic launched what they call the Van Beethoven mobile tour, a wonderful project they did. I think it was actually one of it's the first here in the United States. And so the idea was that they wanted to take the first 5 minutes of Beethoven's famous Symphony No. 5, and Gustavo Dudamel, he's the conductor, their artistic director. And so the idea was to bring this very well-known piece to the general public who perhaps would never have thought of hearing it or have the resources to hear it, but through an immersive 360-degree 3D virtual experience environment. So that's all that I have for slides. I made sure that we would have a good chunk of time left. So I'm completely open to questions, comments, even those of you, if anybody have synesthesia, or even if you don't, if you have had these type of experiences, anybody lives in LA, maybe you saw this, or anything really to kickstart our discussion. Yeah, so I'm going to open it up to you guys. I think I see, so there's in the chat. So I think I have someone who sees visuals and cause to, So there's a question here in terms of somebody who potentially experiences visual scenes or items in the visual, has visual perceptual experiences in conjunction with different music or colors to music. The way to go about and see if you if you are an actual synesthete as opposed to someone who is just, let's say, highly imaginative and creative. Typically, as far as I know, it's looking for labs that do this types of research, and they do have a battery of tests that you can certainly contact. So if I would suggest doing a Google search of labs that work on this, that are open to the public in terms of who are looking for participants and are looking for individuals to study, and I really mean study in a very positive sense. So that's how I would go about with that. With respect to here, any statistics on how many musicians have synesthesia? Oh yeah, and the numbers, I don't know the numbers off the top of my head. As I mentioned with the, so let me go back and share let me go back to the slides. So in this particular slide here, so what I can do is I can send you guys actually the paper if you're interested, where this comes from. They talk about more artists, although these tend to be the most famously cited ones, Scriabin and Rimsky-Korsakov. Kandinsky's work is then, and really any of the literature that's a part of the Dadaist movement, so pre the Surrealist movement. There's a lot on that, and maybe there may be, so you can enjoy going through a lot of those readings. I personally have not seen a nice table of every artist that's known who has synesthesia, so I don't know the stats at all. But I wouldn't be going back to this graph here, which I can share. I can certainly share the paper with you guys. Going back to this graph, this surge in the early 1900s is because so many, not only did Kandinsky, literally because of his work and with musicians and just artists in general and theatrical productions, and the way cabarets and the way when we have the cabarets happening in the early parts of the 19th century, it was big in terms of the public and the media. That doesn't mean that there aren't other artists since then. It just, the media response is different. Social cultural ambiance is different to dealing with this question. So again, I don't know the numbers, but I will share this with you guys too if you want to read further about that. And like I said, more artists are mentioned. Okay, there's another question about what about trauma effects? Fleeting, and can they be experienced? By trauma, do you mean in terms of a traumatic event leads to then a synesthetic experience, or that a synesthetic experience leads to trauma? In terms of, I have read about the synesthetes who can lead to traumatic emotional experience. As the other, so you're saying trauma first. Okay, so does trauma lead to? So I would say that it's not a synesthetic experience, but more of the association type experience that all of us really go through, and that we know simply because it does not tend to be consistent enough to classify as being synesthetic, and it's not an involuntary enough to be considered synesthetic, to be classified as synesthetic. So Leah, let me go back actually to this so that we're all looking at this at the same time. I think also for the trauma question, the unidirectional, that is where actually in the trauma case, it may end up being bidirectional. So I think that may also be the reason why it's not classified as a synesthetic experience and more of a memory association, emotional event experience. obviously with respect to the emotional impact, yeah, that's there. Oh, the additive, that's also, with the trauma, it's not additive. So that will be a very almost sort of focused experience. It's not like you're going to be then also experiencing other things at the same time. So it's a highly, concentrated attention experience with the trauma case. With respect to, so I think I saw more questions here. More to listening to music in B flat, an experience of intense sadness. So yeah, that's a fascinating question. And that one goes back to our conversation about emotion. I remember from these examples I was giving, so let me go to that slide. Where was it? So with these examples, this is still the classical Western world. So these particular associations of the A flat, E flat, B flat with these dark grays and blues, this tends to be more of a Western concept. We're dealing here with the Western tonal map here. So I would be careful with saying that this is something that would happen across different cultures and different musical cultural systems. I would leave that as a question mark. In terms of the intensity of the experience, again, it's extremely individualized. Some people report that it's intense. Some people report that, yeah, I'm sad, but I'm not fully sad. And I think this goes back to, remember we were talking about those different contrasting theories of, do you actually feel the emotion? So is your body going through all the physiological instantiation of the emotion? Or are you just recognizing that it sounds sad because you know what sadness is, and it literally evokes an image of sadness, but you're not actually being sad. So that I would keep it as a question. So I work with VR and I'm interested in the body spatial information processing plus the visuals. So interested in what I would call body feeling with visuals and sound in 360 and research on that. Yeah, there is a lot of burgeoning research in this area. What I can do is I can share, again, I'll share articles for you guys, we'll forward to you about this. One of the big questions in the VR research, and I know this also from my work in autonomous driverless cars, and do a lot of work with people in the engineering field of the sensors, creating all of this. And part of the conferences I assist every year in San Francisco, there's a whole group that works exactly in these very questions of how to make VR more visceral. And so they're literally doing these highly, nuanced experiments about trying to actually bring in the feeling of gravity into the VR experience. And how to use, because it's a 360, if you think about it, when you're moving around in the world, you're not seeing 360, right? I mean, you're seeing what's in front of you, right? Your visual field. You only see 360 if you actually turn around, right? And what's great about VR is that in this world, because it's shot here as a 360, you can be in that world in all ways, from sound to vision, to tactile, to smell, to everything. And so you can imagine that you can create these highly fascinating experiences. I don't know if some of you have seen some of the few VR movies that are actually out that have been created. Creating those films is a very different experience. They tend to be more theatrical. In fact, a lot of filmmakers who have tried to move into VR, make their movies into VR, have said that it's not the same experience. They actually had to enter into the theatrical world to create these different, to create their VR film. And a lot of that has to do with, in terms of having this capacity to experience these, the way sound is, and how you experience sound in your everyday life is going to be different from everything being concentrated in this one experience, in which now your attention is to this world that is that has been artificially created so that you can experience it 360, But when you think about it in real life, even though of course you have a 360 world around you, your attention is not towards everything that's happening in the 360 view. So that's where things become highly, that's where the question is, how do we bring the real world experience into the VR experience, but then take advantage of the VR technology to bring up sort of that's why I said an alternate world of reality, really. There is, in terms of with the music world, it's just started. There's way more on the technical side of it in terms of creating these, the actual camera systems to be able to record all this information. But I will forward you guys a paper about this. So last but not least, question here, is there any clear association between synesthesia and creativity or cognitive performance? No, it's all a classic answer to everything in cognition. So, okay, let me just say it really quickly right now that we're at the end of class. So synesthesia and creativity. We have seen as an example here with Scriabin and Rimsky-Korsakov, Western culture composers that are very revered in the classical musical world that, yes, they are well-renowned composers, amazing, known for very innovative work, who had synesthesia. Kandinsky is another great example, well-known painter who we know his actual, he had synesthesia. So, okay, yes, that is a clear association. With respect to now creativity in general, as I mentioned earlier, there are a lot of examples of artists. Going back, here I go back to our example of Leonardo da Vinci when I was talking about creativity. To my knowledge, I do not think he is known to have had synesthesia. And he's a great example of somebody who was highly accomplished and considered one of the greatest intellectuals of human history. So no, it's not a direct correlation. So you do not have to have synesthesia to be extremely creative. We have examples of highly creative artists who are synesthetes. We have a lot of examples of composers, painters who were well-known synesthetes. But you don't have to have that. Now, in terms of cognitive performance, I'm assuming you mean sort of heightened abilities now, let's say in language, in other highly motoric, or just anything. Again, this goes back to a conversation about creativity that's not necessarily just about the arts. You can be highly creative as a surgeon, as a business executive, as a lawyer, anything really. No, there is no correlation. There are tons of examples of people who are extremely successful who do not have synesthesia at all. So, and I do want to mention that we tend to see these patterns of creativity and synesthesia in the arts, not in other fields. It could, so I do want to mention it could be the reason why we see these patterns is because people, again, remember when we talked about creativity, I said, unfortunately, studies tend to focus just on the arts. So that's an open question. And so I don't want to correlate it with just because people have focused on that and that's it. And we just don't know. So yeah, I think that about, yes, closes these questions, and we're right at a little bit past class time. So thank you, everybody. Wonderful to